We're starting in on section 3 on this problem, and what we need to do is practice applying linear situations into the real world. And that's what we're trying to do to get you beyond just y equals mx plus b, or beyond if you think this is easy. And in this first situation, we just have a person, Dia, who's driving away from New York City at a constant speed of 58 miles per hour. And he started 48 miles away. So anytime I'm trying to come up with an equation of y equals mx plus b, I want to look for some keywords. And one of the keywords I like to look for is starting, is that's typically your y-intercept. And the reason why that makes sense to me is if I ever ask you to graph, and I asked you, well, how do you graph something? You usually start with the y-intercept. So if I were coming up with an equation, I would let b equal 45 because that's the starting place. And my other clue is a couple things. First of all, a speed is typically a rate, and slope is a rate. Slope is a rate. If you're unaware of what I mean by a rate, is written as a fraction, and I know it's written out in words, but miles per hour. That's usually a clue as well that you're dealing with the slope. Rise over run for slope. I'll even write that over here for you if it's been a few days since you remember our discussion on slope. Y2 minus y1 over x2 minus x1. So that would be your 58 is your m. And instead of just using y and x as the problem says, they want you to write the distance, so d, and h is an hour. So instead of y and x, we want d and h. So the final question said in part B, if Dia's destination is 270 miles away from New York, algebraically determine to the nearest tenth of an hour how long. Well, if you reread the directions, since whether D stands for distance or destination, a lot of times that's making perfect sense. So 270 is representative of D, and what we don't know is H. And if you're still confused on why I plugged 270 in for D, notice that the question says how long. Well, how do we measure how long something is? Well, in hours. So H hours. So from here you just have to solve it, and I would just subtract 45 over. Now some of this stuff I think you can do in your head. Some of the other stuff I think you're more than reasonable to use a calculator for. I don't know how good you would be at 270 minus 45, so if you pulled up a calculator and you type that out, I would not be upset. So 225 would be equal to 58h, and then to solve, you could take that answer and divide by 58, and to the nearest tenth, just a reminder on rounding, you look at the next digit. If it's 5 or higher, it bumps up this digit, so 3.9 hours. If you have any questions on how to round, you got to let me know. Otherwise, I'm assuming you know how to round. So as we move forward, we have some clues in here. In exercise 2, we have a cell phone plan that is sort of an outdated question, but there was a time that there's a fixed cost, and we know that she's charged 15 cents per call. And right now, we don't know anything else. We don't know what the fixed cost is, so we don't know what the starting amount would be. But we have 15 cents per call. You know how earlier I mentioned the word per is a clue that that's going to be your slope. So in point slope form, if I remind you on point slope form, looks something like this. All we know is that this slope would be the 0.15. And a reminder in point slope form, we leave the x and the y alone. So the independent variable would be how many calls she makes, because you get to choose how many calls you make. That's what makes it independent. So in this case, I'm going to let 52 be x1, and then the cost depends on how many calls you make. So this would be 1280. And I don't know if that makes perfect sense in your head. It's the ordered pair when x is 52. The y coordinate is 1280. And if you also wanted to, you don't have to use y and x, because in the problem they say p and c. That might help you understand why the c would be the independent variable and p is the dependent variable. But from here, what you would need to do, switch colors, is distribute. And what you'll see on the right side is you'll have 0.15x. Again, I'm not going to expect you to do this math in your head. I mean, you probably could, but it costs $7.80. And then to solve for y, what you would have to do is add that 1280 to the right side. Let's switch colors one more time. And I hope you're okay. I'm going to switch my variables. I know it says y equals, but as I mentioned before, the pay that you have depends on the calls. So I'm switching back from y's and x's to p and c. And let's see, we had that negative 780 that we need to add 1280 to. So the fixed cost, no matter what, she must pay $5 a month and then 15 cents after it. So based off of reducing the problem like that, and I guess I could have stopped up here because they wanted the problem in point slope form, but this will help us answer what her fixed cost is. Well, how can you figure out her fixed cost is if she paid 0 cents, or sorry, if she made 0 calls. And 0 times anything will be 0, so it might make sense that her fixed cost is $5. So in other words, how much would she have to pay for making 0 phone calls? $5. Hopefully that makes sense. If it's still not making sense, you have to write down your questions, bring them to class, let me know, and then we can move on. And hopefully I can answer your questions. So we're going to use a graphing calculator with exercise 3 to try to help you understand a little bit better. So in this example, we're producing widgets, W widgets, and it has a cost equation. So the cost is equal to 18 cents per widget plus a fixed cost. And then they also tell you that each widget sells for 26 cents, and we can see the revenue that it would take. So using a graphing calculator, they just want you to create a graph that looks like this. Now with a graphing calculator, all you can do is go to y equals, just forgot I still had equations in there, and type in those equations, 0.18, and we don't have a button for w, so leave it as x. I'm just typing into my calculator, 0.26x. And notice that the directions say they want to figure out from 0 to 500 widgets. So what I'm going to point out for you is you can change your window to go from 0 to 500. And what you can also do, instead of messing around with your Y's, you can actually hit these buttons, zoom, and then all the way down here, there's a button that says zoom fit, and it takes the 0 to 500 and perfectly fits the curve into my axes like this. And unfortunately, the way I have it drawn, you can't tell my x-axis. But what I can actually do is I can go back to my window and see that it perfectly fit my y values between 0 and 130. And if it helps, you could actually count by, 50s. And maybe over here, you go on the y-axis by 10s. So now when I go back to my graph, 50, 100, 150, 200, it looks like it's crossing at like 250. And then 10, 20, 30, 40, 50, 60, 70 maybe. Somewhere in there is where they're going to intersect. So using that graphing calculator, I wanted to point out that, and you might have noticed that one was in red, and then the other one was in blue. The red one was the revenue equation. And you might notice the Y-intercept was at 0, whereas the other one was a little bit above 20 and was not as steep. 0.18W plus 20.64. You can't see that. Okay, it's that equation. Yeah, and on my x-axis, my w-axis, I counted by 50s. I don't remember exactly where they intersect. But then over here I count them by tens. Alright, for the sake of time, I'm going to skip through that. You can make a better graph based off of your graphing calculator or what I have drawn. So they want you to use the Intersect tool. Where is the Intersect tool? It is second trace, and you can actually find the point of intersection as the 5th option down. So as I hit enter on that, if you notice I'm moving my cursor around, so I don't know exactly where it's going to be, but you want to approximate where your curve hits, and then you have to hit enter 3 times. You have to tell the calculator you want the blue equation, the red equation, and then the closest point of intersection. And now your calculator actually spits out the correct answer of 258 widgets at a cost of $67.08. So the number of widgets that you need, I already forgot, 258. And what that gives us is that the cost and the revenue both equal each other at $67.08. And what does that mean? Is it's going to take you that long before you start to make a profit. So if the profit is defined as the revenue minus the cost, so I'll write P is equal to revenue minus cost, what you can do is you can actually replace the revenue equation, that 0.26W, and then subtract off the quantity of the cost equation, 0.18W, plus that 2064. And when you simplify that, 0.26 minus 0.18 would be 0.08, and that becomes minus 2064. And so if we use a calculator one more time, we can sketch a graph of the profit equation. Here's another trick with your calculator. There's a couple things I want to show you. Is if you hit enter on these equal signs, you could actually not see them in your graph anymore. And then let's see if we have the right equation, 0.08x minus 20.64. Or another tool that you can do is you can actually hit alpha trace, and you can grab the revenue equation, which we define as Y2, minus alpha trace, grab Y1, the cost equation. And now when I change my window, because if you read the directions, I'm hurrying because I'm almost out of time, from 0 to 1,000, and then I hit zoom fit again, what you should have noticed is that black curve and the pink curve are identical because I graphed it perfectly. So from 0 to 1,000, the graph looks something like that. So the directions here ask you to use your table and your window for perfect viewing. And the way I have it set up, I still have it counting by 50s. But what you should notice is that x-intercept is still 258. And the reason why that's still 258 is that's the first time that you start to make a profit. So when they ask what's the minimum number of widgets that must be sold in order to make a profit of $40, what you can do is go to your profit equation and just set it equal to 40. So then you could add that 2064 over, which would be 6064. And then to solve, you have to divide. I'm running out of time. And this would be your answer, 758 widgets.